Okay, given f of x equals 5 to the x power plus 4. It's an exponential. You guys learned exponentials last year. And g of x equals 3x plus 8. That's a linear function. It looks like a line. So, composition of functions means we're going to take two functions and put them together in different ways. The first way is f plus g of x. We're going to add them first. Now, order is very important on this, and what's on the inside is very important. So f comes first. Landon, what was the f function? Good. And then that guy we're going to add. When we're adding, we can put parentheses, but adding really isn't... Oops. We don't really have to have parentheses when adding. If we are subtracting, I definitely want parentheses on my next part. Plus g. Well, isn't g just this guy? And if we're adding functions, or adding polynomials on your last exam, what did you do after you lined them all out? Find like terms. Okay, any like terms here? 4 and 8, those constants. Are these guys like terms? No, actually. So we have 5 to the x power plus 3x plus 12. And I would rewrite f plus g of x. Okay. Now, if I asked for, this one's has an extra part, f plus g of 2, we're still going to add f and g, which we just did on the last part, so I can just skip that step and go straight to this. Because I've already added f and g, but what does this 2 mean? The 2 goes into it, good. So we're evaluating at 2. When you see that 2, you're evaluating, which means you plug in the 2. Wherever there's an x. See, it's taken place of the x. X used to be here, and in place of x, we've now put 2. So we're going to plug in wherever there's an x, I put a 2. Plus 3, does this become 32? By 3x, does that become 32 when I plug in a 2 for the x? This is 3 times x, right? So we get 3 times 2. I'm sorry? It doesn't really matter. You just need to multiply them.
Okay, so just in case you don't think it's a 32, is it okay to make it smaller instead of with the parentheses?
Yeah, you could even write times. You could write it this way. It is multiplication. Then we use inverse operations. What comes first? Exponents comes first. So we go 5 squared is 25. Thank you. Plus 3 times 2 plus 12. Write your work out step by step so you don't make an error. After exponents, Waji, what would come next after exponents? Please excuse my dear Aunt Sally. What comes after exponents? No, parentheses comes before exponents. Please excuse PEMDAS. Please excuse my dear Aunt Sally. We just did exponents, so the next guy in line is... Yeah, so we need to multiply those. 25 plus 6 plus 12. And with addition and subtraction, we go left to right. 25 plus 6 is 31 plus 12 gives us what? 43. And I'm going to rewrite, for good habit, f plus g of 2. Notice this is not times 2, it's of 2. f plus g of 2 equals 43. So that's saying evaluating at 2. This is a function, though. It's when the function is 2. It's different. This doesn't mean times. Yes? Where?
On the end of
4 plus 8 made the 12, so it worked out. But thanks for checking. Okay, now let's look at a different thing. This is our turkey and stuffing. There are 2 different ways to see this. I prefer this way. Oh gosh, I'm going to erase, so I don't have so many parentheses, I'm going to drop that first parenthesis. It's also seen as, it looks like fog. Hey, who just said that? You said it perfectly. How do we read this? Yeah, all those ofs. This is red. F of G of X. Oops. So it means we're evaluating F by plugging in G by plugging in X. We're evaluating twice. F of G of X. So, Duncan, turkey, duck, chicken. Turkey's on the outside, the duck is stuffed inside the turkey, and the chicken is stuffed inside the duck. Duncan. Good stuff. Okay, so I can't see my F anymore. Can you guys tell me what I had for F? What was it? F was 5 to the X. Is it plus or was it minus? I did plus 4, okay. And G of X was what again? 3x plus 8. Okay, so if we want to find f of g of x, start on the outside, who's the turkey? F. And wherever there is an x, I'm going to put parentheses, plus 4. This was the f function, f parenthesis plus 4, because it used to be fx to the x power plus 4. Inside the parentheses where we start stuffing. Well, what gets stuffed inside? The duck, which is G. So where I put those parentheses, I'm going to write 3x plus 8. Now on this one, we're just evaluating at x, so x will stay. On the next one, I'm going to put a number in for there. Okay? Well, let's see. 5 to the 3x plus 8 plus 4. Are there any like terms? What? It's just a constant. It's adding 4. It's right here in the equation. Well, I can put it closer if you want. It just needs to be after the exponent. It's after the exponent. See how x is here? And the plus 4 is after the exponent? It needs to be after the exponent. Okay, so I would check and see if there are any like terms. Doesn't tend to be any like terms. So these exponential ones, I'm doing exponential specifically because you have them on your assignment. But sometimes you have a linear, and then you definitely have like terms. So if I want to evaluate f of g of, let's put in 3, same f and g functions, start on the outside, Duncan, who's the turkey? The turkey was f. So I'm going to write 5 parentheses plus 4. Wherever there's an x, you're going to be stuffing something inside. So that was the turkey. Who's the duck? Duncan. Who's the duck? G. So we're going to stuff G inside of F. G was 3x plus 8, but I have more stuffing to do, so wherever I have an x, I'm going to put a parenthesis, 3x plus 8. And now, Duncan, who's the chicken? Who's the chicken? 3. So we're going to plug in 3. So it's plugging in and plugging in again. All the x's, if there's a number here, all of the x's should be replaced with that number, and there should be no more x's in your function. So then we do, please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. What would we do first, Sean? And please excuse my dear Aunt Sally to simplify this guy. Parentheses, okay? So here's our parentheses. What should we do in there, Sean? Multiply and we get 9. Good. And then we'd add, right? So 9 plus 8 is, oh, this is a big number. Okay, that's why you have calculators, right? Then we do exponents. 5 to the 17th power, that's going to be monstrous. Does your calculator even handle that one? Ooh, this is a good thing. 7 point, read all those numbers, please. Oh, wait. What was after the 6?
2, 9, 3, 9, 4, 5, 3, times 10 to the 11th power.
Ah, do you know what that means? Scientific notation. It means we're supposed to move this decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. Yep. I just chose the 3, so that's my bad picking a number that's going to make this a monstrosity. So we don't know what the last 2 digits are, so that's unfortunately as far as we can go. The ones on your book, though, you're only plugging in more reasonable numbers, so it should be okay. Yeah. If it's to the 5th of 5 raised to power, it either ends in a 0 or a 5. If it's going to be in an odd, it will be a 0 probably. Let's see. No, don't be in an odd, it will end in a 5. Right? Because 5 times 1 is 5. 5 times 3 is 15. 5 times 5 is 25. Okay? So, I'm only giving you 5 problems on those today. Okay? We're going to do another thing here in just a sec. You can pull out a separate